It's a real pleasure to introduce Cecilia, who's doing her master's in conservation biology, and he's also going to be talking about the relationship between Quendas, Phytophthora, cinnamomi, and predators. So it's an important relationship. Thank you very much.
Thank you. Thank you. So hi everyone, my name's Cecilia, and as you've just been told, I'm doing my master's in conservation and wildlife biology at Murdoch. Also have a supervisor in Giles and Tom as well, who just spoke. Click next. And I'm really excited to talk to you today about my project, which is investigating whether Quendas are more vulnerable to introduced predators in the areas that are affected by Phytophthora cinnamomi. Work out which button to go next.
Arrow down.
Down.
Okay.
There we go. Okay, so Australia has a pretty shocking record for endemic species extinction. Over the last 200 years, we've lost more than 10% of all terrestrial species, which is pretty terrible. And the reason for this is largely due to habitat loss as well as predation by introduced species, such as feral cats and red foxes. Now, between these two predators, they have an estimated kill count of approximately 2.6 billion animals per year. That doesn't include the roaming cats that Meredith was talking about before, the domesticated cats, so that number is on top of that 2.6 billion. Previous research has shown that both of these predators do prefer hunting in and have a greater success at hunting when they're in degraded habitats, so following fire or after land's been cleared for agriculture and that sort of thing. And a common mammal that's at really high risk of predation is our local Quendas. They are very resilient and adaptive and very successful urban colonisers, as Tom was saying. And if you're like me, I'm sure there's a few people in the room here who have them in their backyards or in their communities. So they are extremely adaptive. What they're also known as, though, is ecosystem engineers. So one little Quenda in 1 year can turn over approximately 4 tonnes of soil, which is pretty significant for such a little animal. This is a process called bioturbation, and by doing that, it enables a lot of really essential functions such as nutrient filtration, water infiltration, seedling recruitment, and fungal dispersal. So all really essential functions for the health and biodiversity of an ecosystem. So really important that we look after them. And so, but what does all this have to do with Phytophthora? So as we're all experts now, we all know just the impact that Phytophthora-induced dieback can cause to our native habitats. By reducing so much habitat for our native fauna is potentially offering a lot less refuge for these small mammals from predators such as the feral cats and red foxes, and adding to the knowledge that the previous knowledge that we know foxes and cats like hunting in these degraded habitats, we come together to pose a question: are all of these factors combining to overall increase the predation risk to our native animals? So in order to answer those questions, we selected 5 study sites within the Shire of Mundaring, same study sites that Shanika and Tom have both been using up in beautiful Mundaring. These are all peri-urban reserves, and they've been mapped out by Joe from Territory for Phytophthora. We chose these sites as they do have nice large areas of Phytophthora with healthy adjacent sections. So it gives us a really good overview of how both the predators and the native species are using those areas. So in April of this year, I deployed 40 cameras set up in pairs at opposite ends of 20 transects across those 5 reserves. So the cameras are paired, one in an affected area and one in a healthy area, all along those transects, as you can see up in the Alps Reserve photo there. So I'm still working through my masters. I'm about just over halfway. So those cameras are still all out in the field at the moment collecting data. But I'm happy to share some early trends and results that I'm starting to see now with you today. So cats, fortunately for the wildlife, but not so fortunate for my data set, only had 6 individual sightings at 2 of the reserves. It's too small a sample size to sort of have any significant impact at the moment. Hopefully we do see some more, but hopefully we don't. I'm sure you'll all understand that. But yeah, as I said, a bit too small to be significant at the moment, but a little bit more in the Phytophthora areas. Cats are very, very cryptic and can be hard to catch on cameras as well. So we'll see how we go monitoring those cameras. Foxes, on the other hand, are more than happy to have their photos taken. We've managed to capture them at all five reserves quite consistently on just about every camera. We've had a total of 148 individual sightings. 87 of those, as you can see, have been in the affected areas and 61 in healthy areas. So this has been recalculated as a camera trap rate per 100 days. So 1 camera in a healthy area, we would expect to see 3.6 foxes every 100 days. And in an affected area, we would expect to see nearly 5 foxes in 100 days. So as I said, still just preliminary results, but it does look like the foxes are beginning to show a bit of a preference for those Phytophthora areas. Quendas, on the other hand, also very happy to be in front of the camera. We've had a total of 300 sightings just at 3 of the reserves at this stage. We do know that they are present at all 5 sites due to evidence of digging and foraging, but we've only captured them at 3 sites. So as I said, total of 300 sightings, 226 in healthy and 74 in affected areas, which once again recalculated 15 per 100 days in the healthy and less than half of that, 6.4 in the affected areas. So I think we can definitely say there's definitely a trend going on there of them preferring the healthy areas. One thing that I have noticed with the images that we've collected is that the photos that we're seeing in the affected area is usually just a single photo of a Quenda running through, whereas in the healthy area, they're more inclined to, I'm more inclined to have 30 or 40 photos in a row of them digging and foraging and spending time in that area. So that's quite interesting. Yeah. So the outcomes we're hoping to gain from this study is to inform predator management for best practice for controlling those species, as well as guide habitat restoration efforts, and also add to the knowledge base of predation risks to our native species, and also to address that knowledge gap that Tom just spoke about of the Phytophthora impacted fauna. And I'd really like to thank Dieback Working Group for having me here today, letting me speak, and to you all for listening to me. And also like to thank everybody else that's mentioned here. Without all of them, research wouldn't have been possible, and amazing support system. And I'll just leave on a take-home note. Just remember, biosecurity, it's up to you. It's up to me to protect our forests and all of these really cute little critters that I've found on cameras. So, thank you. Any questions?
Any questions? Wonderful presentation.
That wasn't a hand. Yes.
I'll ask one just because no one else is putting their hand up. Can't let you get away that easy. No, really great study. Just curious, did you bait the cameras? And also, do you think there's difference in detectability between infested and uninfested areas, and how might that influence your results?
So the cameras weren't baited because we did just want to see what was naturally occurring in those areas. We didn't want to attract any of the animals in either way, shape or form. I don't think there's much difference in the detectability between the 2 different zones. They Some of the areas are quite, some of the Phytophthora areas are almost, you know, nothing there, just sand, dirt and a couple of logs sort of thing. And some do still actually have quite a bit of ground cover and understory going on there. So I've also been doing vegetation surveys as well to sort of collaborate all of that together and sort of compare those. But yeah, I don't think the actual areas themselves are having an effect on that, apart from the natural movements that they would be doing anyway, which is what I'm looking at. So yeah, does that answer your question?
One more question in the front.
Yeah, so the question was asked if I'm having a look at the movement past the transition areas. Is that correct? Yeah, so the transects that the cameras are on, they're 90-metre transects. So you've basically got 30 metres of healthy area, 30 metres of Phytophthora, and with a 30-metre buffer in between. And those cameras are actually positioned so that they're both facing inwards. So they've basically got a good view of their own area with minimal variables in regards to the weather, the soil type, and those immediate vicinity sort of variables. Yeah.
Thank you very much, Cecilia.
Thank you.
Another example of an excellent piece of research that is desperately needed and should continue.